system. So as an end user, you may not be as familiar with seeing Linux installed onto a desktop or laptop as you would be with Windows or Mac OS. Those two operating systems are much more popular and common for end users on their laptops or desktops. Linux, however, is installed in a lot of places and is really integral to how a lot of technology functions today. A few common things actually in your house that are running Linux, if you have an Android smartphone or an Android tablet, those are actually a version of the Linux operating system. Also, a lot of smart devices and IoT devices are actually running miniature versions of embedded Linux themselves. And then outside of our households, there are millions of servers all around the world that are running Linux, and also outside of our household, the majority of the cloud infrastructures and servers that are running all of those core integral applications that we access on a day-to-day basis on the internet, those are most likely running Linux. In this section of the course, we'll cover some very core topics of Linux. We'll actually start out by learning a little bit of history about the Linux operating system and the Linux kernel. We'll then go out and install our own distribution of Linux, Ubuntu, as a virtual machine. We'll use that virtual machine to learn about the Linux terminal and get used to navigating it. We'll then learn about the different types of users in Linux, including the super user or root user, and how we can use the sudo command. After that, we'll learn about the Linux file system hierarchy, and then take a look at how file permissions in Linux work. Next, we'll have 2 lessons learning about writing scripts in Bash. We'll then take a look at how we can actually schedule scripts or commands to run with cron jobs. And then we'll wrap up with learning about how we can use the package manager to keep our packages up to date and how we can update the operating system in Ubuntu. I'll see you over in the first video. Welcome everyone. In this lesson, we're going to be learning about the GNU Linux operating system. You may recall from our section on operating systems that a very core component of any operating system is the kernel. The kernel, of course, is responsible for interfacing between the hardware and the applications and software that actually run on top of it. To make up a full operating system, we of course need the things like the applications, the software, the file system, and maybe some sort of desktop user interface that runs on top of the kernel. You've probably heard of the GNU Linux operating system just referred to as Linux. However, Linux is only the kernel of the operating system. The GNU portion accounts for the other parts of the OS, like the applications and file system that run on top of the kernel to make it a complete OS. These days, though, you'll mostly just hear Linux used to refer to as the entire operating system itself. I've included an interesting article down below about how GNU, which is spelled GNU but pronounced GNU, and Linux actually came together to be one whole operating system. So if you're interested a little bit more about the history, check out that article. For the rest of this course, I will use Linux to describe and talk about the whole Linux operating system. And if I need to talk about the Linux kernel itself, I'll call it the Linux kernel. And I'm doing so because realistically, this is how you're going to hear it talked about at your job or elsewhere on the internet. Most people just refer to it as Linux. Linux and GNU are both open source. And this means that the source code for it is available for anyone to read, audit, use, modify, or even contribute to. It's also free, however, this does come with some restrictions. Linux is licensed under the GNU GPL, and GPL stands for General Purpose License. I've linked another resource below if you want to read the full details about the GPL. However, the basic idea behind GPL is that software that is licensed under it is open source and free to use, even for commercialization. So if you're profiting off it or using it as a business, it's free to use. However, you must make sure that the source code for it is open and readily available. So you can take the source code, for example, for Linux or for the GNU software, and you can modify this as needed. However, if you do this, you need to make the source code for all the modifications and everything open source and also available. Something you'll even see in the fine print of user agreements or licenses for software that are actually making use of GPL source code or modifying GPL software is that they'll actually even sometimes offer to mail you a CD of their source code, and that's so that they can comply with GPL. Because of the open nature of Linux, it has spawned hundreds of different variations of operating systems which are all built off of that Linux kernel. These variations are frequently referred to as distributions, and you'll commonly hear them called distros or Linux distros. A Linux distro is generally made up of the Linux kernel, packages, which are the software or application that run on top of it, a package manager, which is used to install, update, or otherwise manage the packages, and usually some sort of desktop UI so that users can interact with it. Many distros are purpose-built to fulfill a specific role. One example is Kali Linux, a Linux distro that has been created specifically for penetration testing in cybersecurity. I'll link below a really interesting tree that actually shows all of the different Linux distributions and their offshoots, so you can find out more details about all of the different distros if you're interested. While Windows may rule the desktop operating system market in the corporate world, Linux rules the server world. The majority of backend infrastructure and servers are actually running Linux. Because of this, it's very likely if you have a role as an IT professional that you're going to need to interact with and most likely administer Linux environments. That wraps up this quick discussion about Linux. I'll see you over in the next video where we install our very first Linux virtual machine. Welcome everyone. In this video, I'm going to walk you through how to install Linux as a virtual machine, and we're going to be installing a very popular distro of Linux called Ubuntu. I picked Ubuntu for this course because it is one of the, if not the most popular desktop distros for Linux, and it's a great one to learn on. So let's hop over to the computer now, and we'll take a look at how we can install it. The first thing we'll need to do is actually download the ISO for the operating system. This is the disk image for installing the operating system. So I'll just open up a browser and you can go to ubuntu.com. And if you want to, you can learn a little bit more about Ubuntu from the website here, but I'm just going to go to Get Ubuntu, and then we'll go download Ubuntu Desktop. And then I'm going to download the 24.04 LTS. So LTS stands for long-term support, and this means that you're going to get 5 years of updates for it. So if you choose to use this version, you can use it for a long time and know that you're going to get things like security updates and whatnot for it. So I'm just going to click download here, and then you don't need to subscribe. Just give it a second and it will pop up the download window. Perfect, there's mine. And we'll just leave it named as is. I'm going to save mine to my desktop. So this should take a little while to download. I'm going to start the download, and I'll see you over here when it's completed. Okay, so my download's finished, so we can go ahead now and create a virtual machine from this ISO. So I'm just going to launch up VirtualBox here. Now that I've got VirtualBox opened up, what we're going to do is we're going to click Machine here. We're going to click New. We'll give it a name, so I'm just going to call mine Ubuntu for PhD Practical Help Desk course. And then I'm going to use this folder that I've created here where I hold all of the files and folders and things for my VirtualBox VMs. If you want to, you can create a folder yourself and use that, or just use the default for it is fine. Of course, we then need to pick the ISO image. So what I'm going to do is I'll just click Other here, and then it's going to be this Ubuntu desktop that we downloaded. So whatever version you downloaded, we'll pick that ISO. And then it actually picks up the type and version for us, so we don't have to do that. However, what we will do is we're going to click to skip this unattended installation, and we're going to do that so that we can actually walk through the installation steps and see what they look like. So we'll just hit next here. Now we need to configure the hardware resources that we're going to allocate through our hypervisor. First one is the memory or the RAM. So if you have enough RAM on your computer or laptop, like for example, if you have 16 gigs, then I would recommend bumping this all the way up to 8 gigs. So it's going to be that 8192 megabytes. And if you only have 8 on your computer, then you can maybe run with 4. But I would bump it up to somewhere around 8 gigs. And then I'm going to bump it also up to give it at least 4 cores here. So bump up to, actually I'm going to do 6 for mine. So as long as you stay in the green, then you're probably not going to have any problems with running it. You'll leave enough resources for your host OS as well. So this is going to be good for me. Usually I find when I'm using a virtual machine, I don't really skip back and forth a lot between it and my host. So I don't worry too much about reserving a lot for my host. I'll take as much for my VM as I can, and that allows it to run smoothly. And then if I'm done with my VM, I just pause it or power it off so I can return those resources back to my host. So I'll click next now. The other thing we're going to do is have to create a virtual hard disk. So 25 is the minimum. I'm probably going to give it 50 here, and we can just click next now. Now we can review all of the different settings that we selected. So if you want to, you can take a look through here, and if you're not happy with any, go back, but I'm happy with mine. So I'm going to click finish. Perfect. So now it's going to be powered off, and what we're going to need to do is start this up, and then it's actually going to walk us through the installation of it. So what I'm going to do is I'm just going to hit start. It's going to take a minute or two for this VM to power up. I'll make this full screen so it's a little bit easier to see. And then we get a couple options here in the bootloader. And what we're going to do is we're going to select try or install Ubuntu. This will take a second to start up. And then we're just going to click here and go install Ubuntu. It's going to give us a little pop-up preparing Ubuntu, and it's going to ask us to input some details here. Pick our language, so I'll choose English, hit next. I don't need any of these accessibility options, but if you do, then you can customize those here, so I'll hit next. Select my keyboard layout. I'm just going to use English US. So for connect to internet, we're going to use wired connection. And even if you're on Wi-Fi on your host computer, the way that the hypervisor is actually going to share that network, it's going to appear to be a wired connection for the VM in the guest. So we can just use wired connection here. I'm going to hit next. We're going to choose to install Ubuntu, hit next. We will do an interactive installation. And I'm going to pick the default selections here. All right, and then I am going to install the third-party software for graphics and Wi-Fi. And then we don't need this install support for additional media formats, so I'm just going to hit next here. We can just do this erase disk and install Ubuntu, so this is just going to be for the VM itself. All right, and then we can just set some information here. So I'm going to put my name, Andrew, and we can do computer's name. I'm going to do just Andrew Ubuntu -phd username, and then we'll need to set a password. So you can set your password to whatever you want. I picked the weak password of password so that I don't forget it. Set this however you want. Then we're going to hit next. This is where I am or close to where I am. So if you want to set your time zone, you can do that. Hit next. And then I'm just going to hit install. We'll let this run through here. It's going to take a little while. Okay, so that took a little while for me. Now the installation is complete. So what I'm going to do is just hit restart now, and we'll let this restart. Okay, perfect. So we've now got the virtual machine installed, and what we can do ahead is just go ahead and log in. So log in with whatever you set your password as. Okay, so now that our Ubuntu has restarted and we're logged in, there's a few last steps we need to do to set this up. So I'm going to hit next here, and then we don't need to enable Pro. We'll just go skip for now. So I'll click next. And personally, I'm just going to say no, don't share system data. And then we'll hit next. And I'm just going to hit finish here. All right, and we've got Ubuntu installed. So I'm going to wrap up this video here. And what we'll do in the next video is we'll take a quick look at Ubuntu and how we can configure it a little bit, and also how we can change some of the settings for VirtualBox to make our VM look and run a little bit better. So that wraps up this video here. I'll see you in the next one. Welcome everyone. In this video, I'm going to walk through a few more setup steps for the Ubuntu VM that we installed, including making some changes in Ubuntu itself and also making some changes in VirtualBox. Let's hop over to the computer now. So the very first thing I'm going to actually do is take a snapshot. So just a reminder to do that, we go up here to machine, take snapshot, and I'm going to call this snapshot, I'm going to call it fresh installation. So we haven't done anything other than the installation. And if you want to, you can add a description here so you can remember. But I'm going to click OK. And that's going to go ahead and take a snapshot for us. So it takes a little while to do. I'm just going to let this go off to the side while it's working. So I'm using Linux. I like to take lots of snapshots. Of course, it is good and best practice for any operating system when you're using a VM to take snapshots. However, for Linux, at least in my opinion, and what I found is that it's a lot easier to do irreparable harm to your operating system. There's a lot less protections in place. It gives you a lot more flexibility, but there's also a lot less protections in that you can damage things that are hard to repair. And this isn't going to like break your host operating system or like anything on your computer, but it can really mess up the virtual machine. And it's a lot easier to fix those by just reverting to a snapshot. So I always try and take snapshots frequently or before I do anything major on my Linux VMs. Now that I've got that snapshot out of the way, the next thing I'm going to do is log in. Okay, so we're now at the desktop of our Ubuntu virtual machine here, and I'm going to show how to do a few things using the desktop UI in this video. The one thing I want everyone to keep in mind is that you recall there's many different distributions of Linux, and some of them share the same desktop UI application. So for Ubuntu, it uses GNOME, so some people pronounce it GNOME or GNOME. So you will see a similar desktop UI across other Linux distributions, but not all of them use this. So not everything that I show how to do in this video is going to work on all Linux distributions. With Ubuntu, similar to the Windows Start menu, we have this Ubuntu logo, which we can bring up to show our apps. And from here, we can get to the various apps that are pre-installed. And once we install more apps, then they'll be visible through here. The very first one that I'm going to go to is the settings here. And here we can change the majority of the settings for the operating system. And the first one that I want to do is actually change the display because the resolution right now is driving me a little crazy. So I'm going to change it, and I'm going to make mine 1920 by 1080p. So you can make yours whatever your monitor is. Mine's 1920 by 1080p. So I'm just going to set it to that. And then I'll keep the scale at 100% and hit apply. And I'm going to keep these changes. So you'll see now though in VirtualBox, we have to scroll down to see the bottom here. So what I'm actually going to do is I'm going to go into the full screen mode. So we can change the view up here and we can scale it or auto resize these. But what I just like to do is I like to put it in full screen mode. It looks the best in my opinion. So I'm going to click full screen mode here to make mine full screen. Before we do, I just want to remind you of the host plus F key, which is the shortcut to enter and exit this. And our host key is the right control. So only the right control will actually work to take us in and out of this. So if I hit full screen mode, it also gives us this reminder because once you get in here, it's hard to get back out. You're stuck in here, but if I hit my control plus F, that's going to take us out. So I'll go back in full screen mode. Perfect. And now we are in full screen mode. So on the left-hand side, we've got the taskbar. And if you want, you can customize this like Windows to put it down on the bottom. I like to keep mine on the side. Of course, we have our file explorer, and this works similar to Windows that lets us navigate all of our files and folders of the file system. And in another lesson, we'll take a little bit more of a deeper dive into the structure of the file system for Linux. We've also got the App Store here, and this is pretty similar to other app stores that you may come across. It's an easy place that you can go out and add or install applications that you want. So you can see here, we've got like a calendar, for example, or if we scroll down, we've got things like Paint, we've got even games and things like that that can be installed. So this is one way that you can install applications, and we are going to actually have a full video and lesson on installing applications in Linux. The last thing that I'll show in this video is actually in the top right hand corner here. We do see we've got this pop-up box. So this is some information from VirtualBox itself and not the operating system, the guest OS. But underneath that, if we take a look, we've got this little bar here that gives us a little bit of options. So we can change the network interface here. We've got the wired one. Generally not going to need to change this on the VM. We've also got some other settings where we can power it off, lock the screen, or we can actually get into the settings from there. That wraps up this quick video learning about the desktop user interface for Ubuntu and finalizing our setup. I'll see you over in the next videos where we take a look at using this VM to further learn about Linux. Welcome everyone. In this lesson, we're going to be taking a look at the Linux terminal and command line. I'm introducing this topic a lot earlier in the Linux section of the course than I did in the Windows one, because you'll find that with Linux, there are not as many UI or user interface options for performing administrative tasks as there are in Windows, so it's even more essential to have a good understanding of using the terminal. If it's something that you're not familiar with, I know that it can be a little intimidating at first, but I think that once you get used to the hang of it, it's actually not quite that difficult, and you probably won't want to go back to using user interfaces once you get the hang of the terminal. With that said, let's hop over to our Ubuntu virtual machine and get started. So we can get to the terminal by clicking down here on this Ubuntu logo to show apps, and then we'll click on terminal. Okay, so now that we're in the terminal, let's talk a little bit about what we're seeing. So the terminal gives us access to a shell. And the easiest way to describe a shell is that it is essentially a way for us to issue direct commands to the operating system. And you can configure different shells or have them behave or display differently if you want. However, in this course, we're just going to be using the standard shell that comes in Ubuntu. So taking a look at our shell, I just want to draw your attention to a couple of details. The first one is this section printed in green here, and that's just telling us who we are logged in as and the actual host name that we're in. So this Andrew is the user, and then the @ is denoting which computer we are on or the host name that we are on. And you remember, this is what I created mine to be. Now, this may seem a little bit redundant for a system like this, where of course we know what those are, but a lot of times you will be accessing a shell through some sort of remote connection, and it can be easy to lose track of who you are or where you are. After the colon, we then see two pieces of information. We've got this tilde here in blue, and then we've got the $sign here. So this tilde is actually giving us the location of where we are in the file system, so where we are in the terminal navigated to, and the tilde is short form in Linux for the home directory of our user. We then see this $sign, and what this indicates is that we are operating in the shell as a standard user and not a root or administrative user. So the next thing you'll see is this $sign here, of course, and that is indicating to us that we are operating in the shell or logged into this shell as a standard Linux user and not as the administrator account, which in Linux is referred to as the root account. We're going to talk a lot more about the different user levels and the root account and super user access in a whole other lesson. However, I just wanted to show what this means. If you were logged in as the root account, then you would generally see this instead be the $sign or $sign. Okay, so now that we have an idea about those, I think one of the easiest ways to learn about how to navigate the Linux command line is to just start with a few commands. So the very first one I'm going to run is pwd, and that stands for present working directory, and it just shows us which directory we are in. So you can see here we get the full name for this tilde, which is the home/Andrew. That's the home directory for my user account. This is important to know because all of the commands and files that we access through the terminal are going to be relative to our location in the file system. Okay, so now that we know what directory we're in, let's take a look at the next command we're going to run, and that is the ls command. And that allows us to display the contents of the directory that we're in. So you can see in my home directory right now, I haven't created anything. These are just the standard folders or directories that are created in Ubuntu when you set up a user account. So we've got all these different folders. You can see we've got my desktop, a documents folder, and so on. Let's take a look now at navigating into one of these folders. So the way to do that in Linux is to use the cd command, which stands for change directory. And to use the cd command, we actually need to pass it an argument. So to do that, we just do a space after the name of the command. And for this one, we just pass directly in the name of the folder or directory that we want to navigate to. So let's start by going to our documents folder. you'll notice that I'm typing documents with a capital D. And we can see now that the blue section of our shell is updated and it tells us we're in the documents. And of course, if our shell didn't have this, then we could use the pwd to remind ourselves of where we are. Let's take a look at what happens if we don't use a capital D. To do that, we're going to navigate up one folder level back into our home directory. Instead of having to change directory into the home directory, we can use some shorthand in Linux, which is the ... symbol. That stands for up one directory from where we are. So if we go cd and then ... you can see that this brings us back into our home directory. So now if we want to change directory into documents, however, we don't use a capital D, you can see that it says there's no such file or directory. That's because everything in Linux, including command names, file names, and folder names, are all case sensitive. So let's go back into the documents folder again. And to get there, I'm going to actually make use of a very handy shortcut when navigating the terminal, and that is tab. So if we go cd, and then I'm just going to type DOC, and then if I hit the tab, it's actually going to auto-complete for me based on the contents of the current directory we're in. It knows that there's one called documents. So I'll hit tab here and it automatically fills that in for us. Then we can just hit enter and now we are in the documents folder. So a very handy feature, and I suggest making use of tab. You can also do it for commands as well, not just for folders or file names. So if we just run a quick ls, there's actually nothing in our documents. Let's go about now making a directory. So the command for that is mkdir, and then we need to specify the name of the directory. So let's call the one that we're making test. And you'll notice, even though we made this directory, so if you list it out, we've got the test, we're not in it yet. So let's change directories into that test. And if we list that out, of course, it's empty. So the next thing we are going to take a look at is how we can create a file. There's a lot of different ways to create a file in Linux, but if we just want to create an empty file, we can use the touch command. And then we just need to pass in the name of the file we want to create. So let's create one called test lowercase .txt. And if we list that out, now we've got our test.txt. The contents of this text file, of course, are going to be empty. So let's take a look at how we can add some text to it. There's actually a lot of different ways we could do this in Linux. And I think one of the easiest ways when you're getting started is to just use a graphical user interface text editor. And we can launch that directly from the terminal, actually, is probably the quickest way to do it. So the one that's built in by default into Ubuntu is the gnome-text-editor. And if we were to just launch this program right now through the terminal like this, then it would just open up, but it wouldn't open up any files. However, we can pass it an argument of the file that we want to open, which is that test.txt. And you can ignore those warnings. You see here, we actually now are in the documents test, and we've got the test.txt open. So we can just write hi from, and I'll put my name. So you can put whatever you want here. And what I'm going to do is I'm going to use Control S to save it. And then I'm going to close it. You can see we're back here at our terminal screen. Since I'm at the bottom of the screen here, and just to make it easier to read, I'm going to use the command clear, which is just going to clear away everything that we've written in, and then it's going to bring me back up to the top. So you can do that if you want, but you don't necessarily have to if you want to be able to see what you've run. One command that we can use to view the contents of a file is the cat commands, that's C-A-T, and then we need to pass in the argument of the name of the file that we want to see the contents of. So for us, that is that test.txt. And I'll use the tab there to finish that. We can see that it prints out hi from Andrew, the contents of that file. So some of the commands that we've run so far has required an argument, and that argument so far has just been the name of the file or directory. However, some commands we can pass in arguments that are flags, and these flags can be required or optional, and they change the behavior of how the command runs. So I think the easiest way to show that is with cat, for example, we can access the help. So if we go cat and then --help. So the help option or flag for a command is one of the most useful options. It gives us a lot of detail about the different options and how to use the command. So if we take a look, generally they'll start with a usage, and that tells us how we can use it. So here we see we have cat, and then we can run an option if we want, and then the name of the file. So when we initially ran it, we just ran it with the file. We didn't provide any options because they're optional. However, we can see here that we have these options that we can pass in as flags with the dash command. So one that I'll call attention to is this dash number, or we can use dash dash number and it numbers all the output lines. So let's clear this away and just see how that works. If we run cat -n test.txt, you can see we get the number 1. And then the other way that we can pass in flags or options is if we go cat -- number test.txt, and we can see that does the exact same thing for us. The last command that I want to show that is similar to the help command is the man command. So that's just man, and we can look at the help for that actually. If we go -- help, and we get a whole bunch of details, but if we scroll back up, you can see the usage is man, option, and then we choose what we want to have the man for. So you can use this to actually get the manual for various commands, and they are more detailed than the help is. So let's clear this out here. So let's run man cat to bring up the manual for cat. You can see it's similar to the help, but it actually gives us more details, and we even get a few examples here. And if we want to get out of man, then we just push Q to quit. So both the help for a command and using man can give a lot of details about how to actually use that command. I use them very frequently. So that's all we're going to cover for the very basics of the terminal in this lesson. However, throughout the rest of this section on Linux, I'm going to be demonstrating the majority of administrative tasks and other tasks that we're going to be performing using the terminal. So we are going to be using it throughout the rest of this section, and as such, we will learn a bunch more commands and some useful tips and tricks for navigating the terminal. That wraps up this video. I'll see you over the next one where we take a look at user levels in Linux. Welcome everyone. In this video, we're going to talk about some of the user types in Linux and also how we can run commands as the administrative user from a regular user account. Specifically in this video, we're going to look at regular user accounts and the root or super user account. There are a couple of other types of accounts in Linux for systems and services. However, those are outside of the scope for this course. Let's hop over to the terminal now so we can start taking a look. On Linux systems, you can see a full list of all of the users that are configured and set up for any host by taking a look in the passwd file. And that file is actually located in the etc folder. So we can take a look at it with cat, of course, and we need to specify the full path for that file because I'm currently in my terminal, at least just in my home directory. So to do that, I'm going to go cat and then the / and then etc, another / and then passwd. So if I scroll up to the very top of the file, the first user is the root user. And in Linux, the root user is the administrative user. It's sometimes referred to as the super user, and that's because the root user essentially has all of the privileges. It has access to all of the files and to run any of the commands, which is why we call it the super user. If we take a look at each line in here, it gives us the name of the user, and then there are some configuration details about the account, which we're not going to get into in this lesson. The one thing that I do want to call out, just because we're going to take a look at it when we're looking at file permissions, is that where this X is in the passwd file, this is where the hash for the password for this account used to be stored. However, this was insecure because all accounts have access to this file. So this hash was moved to a file called the shadow file that only the root user has permission to. And we'll take a look at that a little later on in this video. Taking a look below the root user, we see we've got a lot of user accounts here that we didn't actually set up. And these are those system and service accounts that were created by default. So if we scroll down below those though, can see that at the very bottom, here is our user account that we're logged in as. Mine is this Andrew one. And of course, that's the account that I'm actually logged in. So I'm going to clear this away now. And I just want to show one quick command that can be really useful for determining which user you're logged in as, and that's the whoami command. If I run that, I can just see that I am logged in as Andrew. And again, this may seem redundant because of course in our shell we can see who we are, but this won't always be the case for all of the shells that you have access to. Sometimes if you're logged in remotely, then you won't know who you are. So this is a good command to get used to running. So in Ubuntu, the account that you create is not the root account. It actually has limited privileges to what it can access. So an example of that is if we actually go into the Etsy folder. So I'm going to cd Etsy here. And if I list this out, down at the bottom here, you'll see we have the shadow file. And that shadow file contains the hashes for the passwords. And if you're not sure what those are, that's okay. I just want to give an example of permissions here. So if we clear this away actually now, and we try and cat out the contents or list out the contents of the shadow file. So if we go cat shadow, you can see that we get permission denied. And that's because we don't have access as this regular account to read this file. Linux has a very useful tool that we can use in the terminal or our shells to be able to run commands as the super user or root user and get all of its access levels without actually switching to that user account. And that is the sudo command. So you might be wondering, why would we use this and not just switch over to the root account? And there's a few different reasons for that. The first one is for security reasons. It's generally best practice to not log in as the root account and be running things as the root account if we don't need to. There's a lot of different reasons for this, and we'll talk about this a little bit more in the security section, but best practice is to not log in as the root account and only run things that you specifically need to as the root user. The second is that outside of security reasons, it can also just generally be unsafe to be logged in as the root and running commands, because it's possible you could run a command that you don't intentionally mean to, or access or modify a file that you don't mean to. And these can be files like configuration files for the system that if you accidentally deleted them can be very damaging to the system, or even make it so it's not going to work. So what I always do is I never log in as the root user. And when I use sudo, I keep that as a reminder to myself that I need to be careful about what we're actually going to be running afterwards. The third reason is that the root or super user or administrator can configure which accounts actually have access to run sudo, so that not all accounts can. And it can also be more granular in specifying which commands or files can be accessed with that sudo command. So we could, for example, just give an account access to only run one command, for example, with sudo. To see actually what permissions a user account has with sudo, we can use the sudo-l command. So I'm going to type that right now. You'll see here it actually asks me for the password for my account to be able to run sudo. So I'm going to put that password here. And we can see here that the user Andrew may run the following commands on Andrew Ubuntu PhD, and that it is all. And that means that we can actually just run all the commands for all files. We essentially, when we use sudo, we have full access. But what you could see is that this could actually list out various commands that would be allowed. The way that it works on Ubuntu, though, is when you create the main user account, it gets this sudo all permissions. So essentially you can become the root user if you want to. However, it doesn't set you up by default with the root. In this way, it's trying to guide you in using some of those best practices. So just to take an example of how we can use sudo now, if we run sudo and then cat and then the shadow file, can see now that we actually have access to the shadow file. Of course, here is my account, and then there's the hash for the password that I've created right here. In the terminal, we can switch accounts. So if we did want to switch to that root account, we can, and we can use the su command to do that. So we go su and then root. However, of course, if you want to run this command as a regular user, you need to know the password for the account that you want to switch into. I just use Control-C there to exit out of that. Of course, though, we can use sudo as well with the su to just change into the root account without needing the password. So I'm going to run sudo su root. You can see now we are that root account. Of course, we've got the root denoted here, and also that $, well, it changed to the hash to let us know that we are running commands as the root user. So of course, if we run who am I, it tells us we're root, and we can just cat that shadow file now, and we don't need to run sudo. So I'm going to switch back to my regular account here. So just as a recap, the best practices for Linux administration and when you're navigating in the terminal is to not be logged in as root, be logged in as a regular account, and then use sudo when you need to run things as the root user, and really try to limit when you actually need to switch users or be logged in as the root account. that wraps up this quick lesson on the different user levels in Linux and how to use sudo. See you over in the next video where we talk about the file system in Linux. Welcome everyone. In this video, we're going to learn about the standard file system hierarchy in Linux, and in doing so, we will learn about what some of the standard default folders or directories in Linux are used for. So you've probably heard me referring to folders as directories sometimes in this Linux lesson, and technically they are called directories in Linux. However, the term is used very interchangeably, either as a folder or directory. You can use either one, and you'll probably hear me switch between them. With that being said, let's hop over to our terminal now so we can start learning. So for us to learn about the standard file system hierarchy in Linux, we need to actually go to the root of the file system. So you can navigate to that with /. So we're going to go cd and then /, and that's going to take us to the root of the file system. And this is essentially at the very top of the file system. We cannot go any higher than this. Even if you were to, for example, go cd ... go up 1 in the file system, it's just going to keep us in the root directory. So one of the ways that I like to think about it and why it's root is that if you think of a file system being like a tree, where from the root of it, we can then branch out with the folders that are underneath it. And each of those folders can have more folders or subfolders, and they can branch out. And at the very base of it is the root. And so the root of our file system is where all the other files and folders are going to originate from. So of course we can run ls here and see the different folders that are in the root of the file system. So taking a look at all of the folders that are listed here, the majority of them are actually standard to the Linux operating system. So you'll find these on all Linux distributions. And there actually is a standard that lays out this file system, the different folders, and what's to be included in those folders. And that standard is called the File System Hierarchy Standard. And I'll include a link below in the resources if you want to read more about it. However, essentially this standard just lays out the various folders that are required for Linux to operate, and then what should be stored inside of these folders. So instead of actually going over the document, we're just going to navigate to some of these folders right now and talk about what is listed inside of them. So the very first one we are going to look at is the bin folder. So we'll just change directory into that folder right now. We'll cd bin, and bin is short for binary. So if we list this out, this folder contains the majority of the binaries, or as they're sometimes referred to, executables that are required for the operating system to function. And if you actually take a look through all of the different binaries here, you'll see some of the ones that we're already familiar with and have been using, like for example, cat, ls, and pwd. Well, those binaries are all in here. So when we're actually running these commands from our terminal, they're going to be accessing these underlying binaries, which are, if you recall, all the way back to when we were learning about how a computer works. Well, these are those compiled binaries or executables, and when we type them into the command line, it goes and runs them from this location. So we don't need to call these binaries or executables with their entire path like we would other files or folders. And that's because our terminal is configured to go and look in certain default locations for binaries when we type commands into the terminal. And that's why we don't actually need to type the whole path. So let's go back up 1 to the root again. And then the next folder we'll look at is similar to the bin folder. It is called the sbin folder. So we'll change directory into there. And if we list this out, this is actually full of more binaries as well. However, sbin stands for system binaries. So these are binaries that are only expected to be used by the root or super user. So if you take a look actually at some of the binaries here, we scroll up, for example, one of them is the delete user. So this allows us to delete users from the system. And of course, this is something that you would probably only want the super user or someone with administrative rights to be able to run. So let's clear that out and we'll go back up to the root directory. So the next folder we'll look at is the lib folder. And if we just list out the contents of it, this is actually full of all of the libraries that those binaries are going to make use of. So these are the dependencies or external code that those binaries require. So both the binaries in the bin folder and the sbin folder will make use of these libraries. Let's go back up to the root folder. So the next folder we'll take a look at is the user folder. So let's change directory into there. And if we list out the contents of this, you'll actually see that there are some folders that were present in the root directory or the parent to this one that are also present in the user folder. The intention for the user folder is these are files or executables that are not required for the operation of the operating system itself, but are to be used by the end user. And that's why there's a bin folder and even an sbin in here. And they include different binaries that aren't essential for the operation of the operating system. Let's go back up to the root again. The next folder we'll take a look at is the etc folder. This is one we've actually already looked at in a previous lesson. So let's head over there right now. And etc actually doesn't stand for etc in Linux. It actually stands for editable text configuration. So that should give you an idea of what is in this folder. If we list it out, we'll see there is a lot of files, for example, in the .conf format, which stands for .configuration. And this is where we keep those text configuration files that allow us to configure the various binaries and even things in the operating system. For example, we saw the passwd and shadow files were used to configure the user accounts for the operating system. So that's where these configuration files are supposed to be stored. Let's go back up to the root folder here. Another folder we've already touched on is the home directory. So let's go there right now. And if we list this out, we'll actually just see there's one folder here for our user account. And if we go into it, of course, this is our home directory or folder where we can store files or install things that are intended just to be used by the user that installs them, or configuration files for that specific user. If we go back up just one more directory into the home again, of course, there's just one here for Andrew, but if we added other users onto this system, then each of them would get their own home folder. Okay, let's go back to root. And the next folder we're going to look at is the dev folder. So let's go over there right now. And if we list out the contents of this, the dev folder is an interesting folder in that all of the files in here are actually files that represent devices. So in Linux, there is an interesting convention that has been used where most things boil down to being just a file themselves, including, like, for example, if we plugged in a USB device, well, there would be a file in the file system that represents that device that we can read to and write from. So for example, if we plugged in a USB device, then it would have a file that would be created in the /dev folder. Let's go back up to root again. The next folder that we'll take a look at is the boot folder. If we list this out, this is actually what contains all of the files that are required for Linux to boot up. All right, we'll go back to root again. And then we'll take a look at the opt folder. So if we go into opt, and there's nothing here, and that's because opt stands for optional, and this is designed to be a folder where we could install optional software if we wanted to. So that's why it's empty, because we just have this fresh install of Ubuntu. We haven't installed anything here, but if you wanted to install additional software, then the opt folder is a place to do that. We'll go back to the root here. The next folder we'll take a look at is the temp folder. So let's cd into temp, it's temp. And if we list that out, you can see we've got a bunch of temp files, and the intention of the temp folder is where both the operating system or users can write temporary files to. And these are temporary in such a way that actually they do not persist between reboots of the operating system. So if you put stuff here and then reboot your system, it's going to be deleted. So keep that in mind if you're ever using the temp folder. Let's clear this out here. We'll go back to root. The next folder we'll take a look at is the var folder. So let's head over there right now. We'll list this out. And var stands for variable. So these are files and folders that are going to store variables that the operating system needs while it's in use. So these are going to be written to and change as the operating system is in use. So for example, you see you've got one for crash where we could store like crash statistics, and there's various other folders and files that store variables for the operating system. Let's go back up to root again. So the last one we'll look at is an interesting one, and that is the proc folder. So we can go cd proc, and we can list out the contents of this, and we see there's just like a bunch of a lot of numbers here and a few other files. And the proc folder stands for process, and it's an interesting file system in that it's actually not written on disk. It's actually created by the operating system in memory. And what it is for is actually to keep track of all of the processes that are running. So that's why we see a bunch of numbers for the majority of them. So this is not a standard file system in that it's somewhere we could write with. It's mostly just used by the operating system to keep track of processes. In this lesson, we touched on the most important or core of the folders inside of the standard file system hierarchy. However, we didn't go into all of them. So if you are more curious to learn about this topic or you want to see what all of them are, then I would encourage you to go check out the resource that I've listed below. That wraps up this lesson. I'll see you over in the next one where we learn about Unix or Linux permissions. Welcome everyone. In this lesson, we're going to be learning about Linux file permissions. These are actually what control who can read, write, or even execute different files in Linux. Let's hop over to the terminal to get started. If you're following along on your terminal from the last lesson, I've moved over to my home directory. So just a reminder to do that, you can use the cd command and then the short form for the home directory is tilde, and that will get you into the home directory. I'm in mine. For this demonstration, we're going to make use of the folder and file that we previously created. So those are in the documents folder, and then furthermore, if we list this out, we have that test folder. So I'm going to go into that test folder directory. So I'll clear this away, and I'm actually just going to make the font a little bit bigger so it's easier to read. We can see the file permissions for a file and actually a bunch of other useful details if we add the -L option to ls. So I'm going to do that right now and go ls-l. And we see that along with just the files that are here, folders that are here, we also get a bunch of other details. So let's talk briefly about what these other details actually mean. So I'll split these up into the different sections of what they mean. The first one is right here. And this actually denotes the file type. So I'll just write that here, file type. And there's a few different types of files, but the two main ones that you're going to see is this dash, which is for regular files, or a D for directories. The next section here, which goes from here all the way down over to here, these are the file permissions themselves. And we'll actually go into more details in this lesson about what each of these mean, but let's take a look at the rest first. So the next one here, where it says Andrew, this is the owner of the file. So since I created this file, I'm going to be the owner. For yours, it's of course going to say the username that you created. The second one here, which is Andrew as well, this is actually the group for this file. And we haven't actually talked about groups in Linux yet, but they actually are kind of just what they sound like. They're a group of users. And the reason that we would do this is because we can add users to a group and then give files permissions to the group that is associated with that file. And it's a really easy way for us to, for example, give different access to files for a group of users without actually having to do it for each individual user. So it is an administrative tool. Next thing that we have right here is the file size. So this is just the size of the file. And then here we have the creation date. So this is when I created this file. And then the last one here, this one's pretty obvious, but this is the name of the file itself. Okay, so now that we know these different properties that are listed when we see ls-l, let's talk more specifically about the file permissions. So within the file permissions, there's actually another 3 groups that we'll call out. So we've got one right here, another one right here, and then the last one is right here. So the first one right here, that I'll just bring an arrow down here so we have some room. These are the permissions for the owner of the file. So I'll just write that here, owner. And then this one right here, bring it down so we have some space. These are the permissions for the group that's associated with the file. And then this last one right here, this one is for everyone else. So for security and access, this is an important one to pay attention to because essentially this is what lets anyone be able to interact or access with this file. Inside of each sets of these permissions, there are 3 properties that can either be turned on or off essentially. And those are R, for read, W for write, and X for execute, so whether it's executable. So you can see in the owner of this group, it is able to read and write, which makes sense, and not execute because this is a text file, so it's not executable. The group is able to read and write, and then everyone is just able to read. So one way that you will hear the permissions be talked about is actually with a numbering system. So for example, this file right here would have 664 permissions. And that's kind of confusing when you first hear about it, but if you actually break it down, it's not that complex. Essentially, the way that it works is each set of permissions, so that's the owner, group, and everyone, well, you basically just add up the binary value if you assigned a binary digit to each of these. So read, that gets 4. Write, if it's on, that gets 2. And X, if it's on or executable, that gets 1. So that's how we get a 6 for the first one. We have read and write, 4 plus 2 is 6. For the group, we have read and write, 4 plus 2 is 6. And then for the last one, for everyone, we just have 4. So that allows everyone to read it. And this numbering system comes into play if we want to change these permissions. We'll need to know how to calculate them using this numbering system here. So I'm going to clear this off the screen here, and then let's take a look at how we could actually go about and change these permissions, change the user, and change the group. So the first thing that I'll show is if we wanted to, for example, change the permissions of this file. So let's say, for example, we did not want to allow everyone to be able to read it. We wanted only the owner or the groups to be able to read it. So if we just do ls-l, actually again really quickly, you can see that we have read, write, and read, which we calculated as that 664 permissions. So the command that we can use to change the file permissions is the chmod command. So that's chmod. And the way that this command works is we'll then specify the first argument, which is the permissions in that numerical format that we want for the file. So if we want to leave the owner and group permissions the same, then those would just be 6. And if we want to get rid of all of the permissions for everyone, we could put 660. And then we need to put the file that we want, so that's that test. And I'm going to use tab to complete it. And now if we go ls-l, now we can see that actually not everyone has those read permissions, only the owner and the group do. The next thing we'll take a look at is how to change the owner of this file. And we do that with the chown command, that's chown. So we'll go chown. Then we need to specify the user that we want to set as the owner of this file. So I'm going to change it to root. And then we just need the file name. So it's test.txt. We can see here that operation not permitted because I am not able to specify it as root, but we can use sudo, of course. So we can go sudo chown root test.txt. And if we give my password, then it's going to allow us. And if we go ls-l here, you can see that now root is the owner. So I'll just clear this out quickly. You can also use the change group command to change the group. So that is chgrp. And we're going to change this to the root group. We're going to need to use a sudo for that as well. So we'll go sudo chgrp root, and that's that test.txt. Now if we go ls-l again, you can see that the owner and the user are root. So I'll just clear this away again quickly. And if we now try and read out the contents of this file, so we go cat test.txt, we can see that we have permission denied. And that's because if we just go ls-l again and take a quick look, well, now the owner of the file is root and the group that's associated with the file is also root. And we took away the read capabilities for everyone else. So that's what's denying us now from being able to read this file. So I'm just going to give a quick hands-on assignment right now, and I'll get you to pause the video after I explain it and then try and do it yourself. So what I'll get everyone to do, if you want to follow along, is go back and change the owner and the group of this back to yours. So for me, it would be Andrew, so whatever your user is, and then modify the permissions so that the owner can read and write, the group can only read, and everyone can read. So you'll need to calculate those file permissions yourself to be able to do that. So pause the video here and then come back when you're done. Okay, so I'm going to show my solution of how to do that now. You may have done yours in a different order, and that is totally okay. But the very first thing that I'm going to do here is I'm actually going to change the owner back to myself. And then I'm going to change the group as well. Okay, perfect. So now if we go ls-l, we have the owner and group done, but we still have the wrong permissions. Our permissions now, of course, are that 660. So now I'm going to use chmod here to change the permissions. And we said that we wanted read write for the owner, which it is that. And of course, that read write is 4 + 2 + 0, which is 6. And then we wanted just read capabilities for the group, so that is 4. And then we wanted everyone to be able to read as well, so that is another 4. Remember, the read is the 4, the write is the 2, and the executable is the 1. So we add whichever of those that we want to be turned on. So in our example, it's 644, and then of course we need the file name, which is test.txt. So now if we just run a quick ls-l here, and we see we get those proper file permissions and the owners back. There's one last thing I want to show before we wrap up this video. So if we go back up one more directory into that documents and we go ls-l just to see what a directory looks like. Of course, we can see here, because it is a directory, we have this D turned on. And just the other one thing I want to call out is that directories are generally executable. And this is what allows the owner or the groups or everyone to actually be able to go in and traverse that directory. So if we want to give access to a directory, then it will be executable. So understanding and setting the file permissions are very, very critical in Linux, because these are actually then what controls the access that various users have to files and are what actually allow us to perform security and have people not be able to just access all of the files in the file system. That wraps up this video here. I'll see you over in the next one. Shell, welcome everyone. In this lesson, we're going to be learning about writing bash scripts. Now, bash is actually one of the most common languages used for a shell inside of a terminal in Linux. And up until this point in this section, we've actually been using bash inside of our shell. However, we have mostly just been issuing it one-line commands. So when we run a command, we hit enter and it runs what we typed in. And then if we want to string together multiple things, like for example, we want to make a directory inside of a directory, well, we have been stringing together multiple commands to be able to do that. So we could, inside of our terminal, actually chain together multiple commands and then have those run one after another. However, this can be cumbersome and it's not easily reproducible. So one thing we can do to actually automate tasks inside of Linux is we can write these scripts inside of a text editor and then save them, and we can recall these scripts later to be able to automate tasks and have them run through a set string of commands. And that's what we're going to be taking a look at in this lesson. So as with some other topics in this course, writing bash scripts could be something that you took an entire course itself on. And my intention for this video is just to introduce you to some of the core ideas behind bash scripting and how you can start to use it to automate tasks. If it's something you're interested in learning more, then I'm going to link some resources both from TCM Academy and then also out from on the web that you could use to learn more about bash. This is really just going to scrape the surface of it. So with that being said, let's hop over to the terminal now and start writing our first script. To give you an idea of what this script is going to do, I'm going to introduce a scenario of something that you would maybe frequently repeat. And that's going to be backing up a folder. So if we actually go to the root directory and list that out, we have that confidential folder that we created in the last ticket interrupt. One thing that we would maybe like to do is take a backup of that, maybe a daily backup. So what I'm going to do for this lesson, so I'm not constantly having to type sudo when I'm teaching, is I'm going to switch over to root. So I'm going to do that with sudo su root. And if you want to, you're more than welcome to also switch over to root and then switch back to your user. Or if you want, you can just use sudo for all of the commands. So I'll switch over to root. What I'm going to do is I'm going to make a directory called backups. Use a capital. And let's just say every day we want to create a folder inside of backups that has the current date as the name of the folder, and we'll copy the contents of that confidential folder over into that newly created folder inside of backups. So we know pretty much all of the commands that we could manually do this every day, but of course that would get a little tedious every day to have to run through those. Maybe it would be like 6 or 7 or 8 commands to do that every day. So what we can do, and what we're going to do in this lesson, is we could write a script that automates all of that, and then it would be as simple as just calling that bash script, and it would take care of that backup process for us. So I'm going to put this script in the opt folder. You could really put it anywhere. I'm just choosing to put it there. So what I'm going to do is I'm going to cd over to opt, and I'm going to edit this script in the GNOME text editor. If there's another text editor you're more comfortable with, like Vim or something like that, you're more than welcome to do that. So to launch that from the terminal again, it is gnome-text-editor, and I'm going to pass it in the name of the script. So we'll just call it backup. And then the file extension for bash scripts in Linux is .sh. So it's best practice and sometimes necessary at the start of all scripts in Linux to add what's called a shebang. And the shebang does 2 things. One, it indicates that this is actually an executable script. And the second is it tells the computer what interpreter or language it should be using for that script. So shebangs start with 2 special characters in Linux. So it's going to be the hash sign and then the exclamation mark. And then after that, we can specify the interpreter or language to be used. So for us, it's /bin/bash. After the shebang, what I'm going to do actually is add a comment that just tells readers and also as a reminder to ourselves exactly what this script does. So if you're not familiar with comments, they're a way that we can leave human readable text inside of the script that's essentially ignored by the computer. To add a comment in bash, we just use the pound or number sign, and then we can write our text here. So let's write out what this script is going to do. So this is a script to back up the contents of /confidential to /backups/ and we'll just go date here, and we'll say where date is the current date of the backup. Perfect. So that helps us remember what the script is for, and if anyone comes back and reads it, they'll get an idea of that. If we were to try and tackle this task manually, we actually know most of the commands that we would need to do. If we were doing this manually, one of the first things that we would do is to create this folder. So we would maybe do something along the lines of make dir, and then we would go like backups, and we would actually start typing out the date. So something like 2024, and then, maybe month or day. And that would allow us to make the directory. Of course, since we're having the computer do this for us and it's going to be running the exact same script every day, we need a way to tell it to make the directory for the current day. And one of the easiest ways to do that is for us to actually use a variable that when the script starts up, it checks what the date is, saves that into a variable that we can then use later in our commands like make directory, for example, to have it create the directory for the specific date. So let's do that right now. I'm just going to add a comment so that it makes it easier for our code to write. So we can say like storing the current date. So the first thing we'll need to do actually before creating a variable even is to find out a command that displays the current date. And the way that I actually did this and to figure out how I wanted it in the formatting that I did is I just went out to Google. So if we just pop over though to the terminal quickly, I'll show you the command that I figured out. So I'll just click this button here to add another tab. And the command that we're going to use is date, which it just specifies the date. However, I didn't want all of this extra stuff in my folder. I just wanted it to be in a much clearer format. So if we go date and then we run +%f, you can see that it gives us in the year, month, day format, which is going to be much cleaner for our folders. So let's just hop back over. So we need a way to store the output of that command into a variable. And the way that we do that is if we just write out our variable and we go equals, and then if we use the $, and then open and close brackets, and then whatever command we put in here. So if we just run that one again, so for example, date +%f, that means that the output of that command is going to then be taken and saved into this variable. So now that we've got the date, maybe one thing that we would want to do is we would want to go echo, which all that the echo command does is actually just print out into the terminal whatever we pass into it as an argument. So we'll use quotes because we're going to pass in a string, and we'll say current date read as, and then we can pass in our date variable here. And when we're using it as a variable, we'll use a $sign again, and we'll go date, and we'll close those brackets. So just to really quickly recap why we're putting the $sign in front of the variable. So we have this $sign date. In Bash, if we want to reference a variable and use the actual value that's being stored inside that variable, then we put a $sign in front of that variable. And essentially what that is telling the script is that when it comes across this $sign and then the variable, find what the value that's stored in the variable and use that in this location. So in our example, it would of course be that year dash month dash day format, but really it could be whatever is held inside of this variable. It could be a number or any other format. So what we can do now is I'm actually just going to hit Control S to save this, and we'll head over to our terminal here. I'll switch over to root in this terminal as well, just to make it a little bit easier. So if we head over now to the opt folder and we list it out, we've got this backup.sh script, and we can actually call this from the terminal. So if we try and just, for example, we can go backup.sh, and we see we get the error here that command backup.sh is not found. And the reason for this is that our shell is actually configured to look in specific locations when we run a command for the underlying binaries or scripts that are actually going to be executed when we issue that command. And the variable that stores these is called the path variable, and that is PATH, all in capital letters. And we can actually take a look at the contents of this variable if we go echo, and then we'll use the $sign and then path. And then inside of this is all of the locations that our shell is going to look when we issue a command to see if it can find the underlying binary or script for that. So for example, you see we've got like user local sbin here. We've got user/bin. And you may recall from the Linux file system hierarchy video that these were all the standard locations where those executables would run. So for example, we have the command who am I, and of course that runs and shows us we are root. And if we want to know where exactly the underlying binary for this who am I that we're running, we can use the which command, which who am I, and it shows us that that is in user/bin, which of course is inside of our path. So if we wanted to be able to call this script from anywhere, even inside of the opt folder or outside of it, what we could do is we could add the opt folder to our path, and then any binaries or scripts in there we could then directly call with their name. The other option, if we don't want to do that, is that we can tell the shell to actually specifically look in the folder we are in for that script or binary, and we do that by putting a / in front of it. So I'm just going to do that right now. We'll take a look. I'll clear this first. And if we go / and then we go backup.sh here, well, now we're getting a different error, but at least it was able to find it. We see we get the error permission denied. And we're getting that error even though we're root. The reason for that is if we just run a quick ls-l again here, can see that taking a look at all of the permissions, even the one for owner, which we're the root here, it doesn't have the X for executable, and none of them do. So for us to be able to actually execute this script, we need to set the permissions so that at least the owner, if not everyone, has executable. A shorthand to do this with chmod, if we didn't want to go and recalculate those numeric permission values, is we can actually make a file executable for everyone by using chmod, and then we can go +X to add executable. And this is going to actually add it for all of those permission groups, so the owner group and everyone. And then we just need to put the file name. So that's that backup.sh. And now if we run ls-l, you can see that we have executable for everyone. And you also see that the color of the file name changed to green. And the way that our terminal is configured to display these file names, the green means that it's actually executable. So it's just a quick way for us to see as well. So now we can actually go ahead and just call this script. So we'll go /backup.sh. and it runs. So that's exactly what we were expecting to see. So we'll wrap up this video here. And then in the next one, we'll continue with writing the script to add the functionality to make the directories we need and copy the files over. So that wraps up this video here. I'll see you in the next one. Welcome everyone. So we're at a ticket interrupt here. Just as a really quick reminder on the format of how these works, I'm going to hop over and read through a ticket that is going to give an example of a real world problem that I think you would need to tackle in a ticket, and allows us to practice some of the skills and different things we've learned in this section so far. So I'll hop over there, read through the ticket, and then once we're done with that, we'll go to a pause here screen. And what I'll invite you to do is, if you would like to try and solve the ticket on your own, which I encourage you to do, pause the video there, go and take a shot at solving the ticket. And even if you can't get it, that's okay. Just take a shot at it. And once you're done, or if you need some help, you can unpause the video and then I will go over the full solution. And also just another reminder that in this ticket interrupt, and like some of the other ones, I haven't actually shown all of the specific commands that you're going to need. So you're going to have to go out and do some research, do some Googling. I think everything that we've learned up until this point will give you enough background information that you could go out and Google to find the specific commands you need to do for the additional details. With that in mind, let's go take a look at the ticket. Okay, so this ticket, the subject is add users to Linux host. And if we take a look, the comment says, hello admin, please add 2 users to the Ubuntu Linux host, Bertram and Ehrlich. You can leave all additional details such as last name, room number, and phone numbers blank. Please create a password for each of them and then expire their password, so they need to create one on their first login. Also, please create a new folder in the root directory called confidential. Make root the owner of the folder with full permissions. However, allow Bertram and Ehrlich full permissions to the folder. Ensure that everyone else on the computer has no permissions so they can't access the folder. Thanks. So go ahead and pause it here and I'll see you over in the solution. Welcome back everyone. I'm going to hop over to the Ubuntu VM right now and we'll take a look at solving this challenge. So the first thing I'm going to do is I'm going to launch up 2 things here. So I'm going to launch up a terminal. And the second thing I'm going to do is I'm actually going to open up a notepad here. So we'll go to our text editor. Then I'll create a new note here. And what I'm going to do is just add the quick details of what we need to do for this ticket so we can remember them. So we're going to go add users. And then we're going to be, Bertram is user 1. And then the second one is Ehrlich. Then we need to reset their passwords or expire their password. So expire password. And then it says to create new directory, confidential, in root directory, set owner as root, give Bertram and Ehrlich full permissions, everyone else no permissions. Okay, so there's a few things we need to do, so let's just go over them. First, of course, we need to add these 2 users, Bertram and Ehrlich, and then we need to expire their password. And then after that, it looks like we're setting up a confidential directory in the root directory. We're going to set the owner as root, which we already know how to do. And then we need to give both Bertram and Ehrlich full permissions for access to that directory. But then we need to make sure that everyone else has no permissions. So one of the easy ways that we can do that, of course, is that we can create a group, add Bertram and Ehrlich to that group, and then set the group for that folder to be the group that we created to give Bertram and Ehrlich the full permissions. So there's one extra thing then we're going to have to do here, and that is going to be create a group. And it doesn't specifically tell us to do this, so we can call it whatever we want. Maybe we'll just call it the confidential group. And then we're going to add Bertram and Ehrlich to the group. Perfect. So now that we've got the details of what we need to do, let's start checking them off. Okay, so the first thing we'll do is we'll just add those 2 users. And to do that, we can use the add user command. It needs to be run as root or with sudo. So we're going to go sudo, and then it's going to be add user, and we'll do Bertram first. and it asks us to create a password here. So I'm just going to use p@ssw0rd exclamation mark for that. You can use whatever you want for it. So we'll go capital P@ssw0rd exclamation mark. Full name, we'll just go with Bertram here. Room number, so it said we use room number and phone numbers blank, so we'll just leave that all blank and we'll say yes, this is correct. All right, and I'll clear this and then we'll just do the next one. So I'm going to go sudo add user, and it's going to be Ehrlich for the next one. Use the same password, p@sswrd exclamation. Perfect. So that's p@ssw0rd exclamation. So you can use whatever passwords you want for this. And if you were doing this at a real organization, then most likely your organization would have some sort of policy for how we're going to create these initial passwords. What we're going to do is we're going to set it as those, and then it asks us to expire them. So the first time they'll log in, then they will have to set those up. So we'll just put the first name here. It is Ehrlich. And then of course we can leave the rest of these blank. All right. Yes. Perfect. All right. So let's clear these out. And if we take a look back at our text editor here, so we did add those users, then it asks us to expire the password. So let's go ahead and expire their passwords right now. The command that you can use to change or interact with or modify passwords is the passwd command. Again, that one is going to need to be run as root or with sudo. So we'll go sudo passwd, and then we're going to pass it the --expire to expire the password. And we'll just give the username of the password we want to expire. So the first one is Bertram. Perfect. And then we'll just run that same command again. So a quick tip for navigating the terminal: if you want to repeat the same command that you just entered, you can use the up and down keys to actually access the history of what you've typed into the terminal. So if you hit up once, then it will just bring up the last thing you did. This can be handy when we're, for example, rerunning a command, but we're just specifying a different argument like a user, because we can just now erase Bertram's name, add Ehrlich, and then rerun this. So just to double check and make sure this works, we can try and su to switch over to Bertram. And it asks us for the password. So for me, I used capital P@ssw0rd exclamation. And then perfect. So we get this: you are required to change your password immediately. Administrator enforced changing password for Bertram. And then if we just give a bad password, so I'll just put PASS. We'll just do that a couple times. And it's going to kick us back out here. Perfect. So now we know that we've done that properly, and they will have to actually rechange their passwords when they log in for the first time. Let's take a quick look back at our text document and see what we've done here. Okay, perfect. So we have added the users, we have expired their passwords. So the next thing it's asking us to do is create a new directory, confidential, in the root directory. So let's go ahead and do that right now. We'll go cd, and then we need to go to / to get to the root directory. And if we just run a pwd, we can confirm we're in the root directory. And then we're going to need to make a directory here. So we'll do that as sudo as well, mkdir, and then it was called confidential. Okay, and you'll note that I did use the capital C here because that's how it was provided to us. And of course, remember that Linux is case sensitive. And if we just go ls here again, we can confirm that we see there is this folder called confidential. So let's just list this out now. And if we scroll up to take a look at this confidential directory here, you can see that root is the owner, so that's perfect. And the owner of it does have those full permissions, which is exactly what we wanted. However, we don't have the right permissions for Ehrlich and Bertram, and we also have the permissions set for everyone that would allow access to this confidential folder. So let's take a look at how we can fix that. We know that we can create a group, and then we can set the group for that folder to be that group, and we can add Bertram and Ehrlich to that group. So let's go ahead and do that right now. We will add a group, and we were going to call it confidential. The command for adding a group is called add group, and we'll need to be sudo for that as well. So we'll sudo add group. We're going to call it confidential. The command to add users to a group is usermod, and we need to run that as sudo or broot. So we'll go sudo. It is user mod, and then we need to pass it the options -a and -G. And then we pass it the arguments of the group name and the user we want to add. So the group name is confidential, And we'll go Erlich here first. Perfect. And then if we just go up to bring that command back, and I'm going to go and run Bertram now. Perfect. So we've got them added to that group. So you may recall the command to actually change the group is that change group command, which is chgrp. So, and we need to run that as sudo. So we'll go sudo chgrp. And then we need to specify the group name, that's confidential. And then we need to specify either the file or directory for that. So ours was the confidential directory. Hit enter. And now if we go ls-l, scroll up and take a look. Perfect. So we now have root as the owner and confidential as the group. Now the last thing that is incorrect here is we don't have the right permissions for the group and for everyone. So these, remember, right in here, this RWX, that's root, and that's correct because they have all permissions for the owner. However, the group, we're missing the write permission here. We just have the read and the execute. And then we wanted to get rid of all of the permissions for everyone else so that other users cannot access this folder. So let's go ahead and do that right now. I'll clear this out here. And we're going to need to use the chmod command to do this. So we'll go sudo chmod, and then we want the owner, which is root, to have everything. So that is read, write, and execute, which is 4 plus 2 plus 1 is 7. And then we wanted the group to also have all of the permissions. So that's going to be 7. And then we wanted everyone else to have none. So that's going to be 0. And then we just need to set the name of that directory, which is confidential. And I'm going to use tab to actually auto-complete that. Perfect. So now if, for example, we try and go cd confidential, it's going to tell us that permission denied, which that's exactly what we wanted because we are logged in as Andrew. So I'll just clear this away. So we tested to make sure that everyone doesn't have access, but let's just run a quick test here to prove what we did worked. We'll log in as Erlich. We'll have to set a password for that, and that's okay since we expired his, but then we'll check and make sure that we actually have the access as that user to get into that folder. So I'm going to go su Erlich, and his password that I set at least was capital P at ssw0rd exclamation. And then it's going to ask us to change the password. So I'll put that password again. And then I'll just set his new password. You can set it to whatever you want. Perfect. So I'm in there. So let's just list this out again. We've got that confidential. So I'll go cd confidential. Perfect. And we can see that Erlich is able to get in. And if I wanted to, for example, I could go touch test.txt. So I can also write to that folder as well. So that wraps up this ticket interrupt. Again, if you didn't get all of these, and that's okay, just take great notes. And then the next time you need to administer users like this, you will have your notes to do it. And if you did do it, then great job. So that wraps up this video here. I'll see you over in the next one. Welcome everyone. In this lesson, we're going to pick up from where we left off in the last video with our bash script. We're going to take a look at now adding the directories using that variable that we created, which stores the date, and then we'll copy the files over from the confidential folder into that directory. So let's hop over to the terminal now and get started. Perfect. So the next thing we maybe want to do is now create this directory. So we can actually do that make dir now. So let's go mkdir. And then the location for that was /backups. And then it was /, and then we want the date. So we can just again call this like this, $date. And let's add a comment here too as good practice. So we'll add a new line and we'll go making directory for the current date inside backups. Perfect. So we can save this and then I'll just tab over here and then let's just rerun this again. Perfect. And then if we go back up into the root directory and we go into backups, we've got that directory for the current date. Now that we've got that directory created, our next step is actually going to be to copy the contents of confidential over into that backup directory we created. Let's start with a comment to indicate what we're doing. So we'll go copying confidential directory. We'll do backup directory. Perfect. And then the command for making a copy is cp. And we're going to issue it the option -r for recursively. So what this means is if it encounters a folder, it's going to go inside of that folder and also copy the contents of that folder as well. And then we need to pass it the name of the directory or files that we want to copy. So in our example, it is a directory. We're going to go /confidential. And we'll go /*, which is going to say go inside of that and copy everything inside of that directory. And then we need to specify the directory where we want to copy it to. So that directory is that backups / and we'll use the variable sign of date so that it goes into the folder or directory that we just created. So perfect. So now we can just save this. And I'm going to go tab back over to our terminal here. And before we run the script, what I'm going to do is I'm going to go into that confidential folder. And if we list that out, we just have this test.txt that if I cat that out, it's blank. So what I'm going to do just as a demo here is let's create another file and we'll add some text to it. A shorthand or easy way to do this in one line on the terminal is we can actually echo text into a file. So we'll use the echo command and we'll just say like hello backup. Then using the > symbol, we can actually take the output of this and actually pass it into a file. So we'll go hello.txt, and since that doesn't exist, it's actually going to be created here. So if we go ls and then we cat out hello.txt, we get hello backup. So let's go over to our opt folder now. And if I just clear this out, we can run that command again. And we can see that our script, once it gets to that make directory command, it actually fails because that file exists. So for our testing, let's go and remove that file, but let's keep that in mind as a way that we can improve our script that we're going to go back and improve it after. So we'll go back into backups and we can use the remove command, which is rm, and we're going to use -r for recursively, and we'll specify that folder. So if we just go 20 and then tab, it will finish for us. And now if we list this out, it's gone. So we can go back to the opt folder now, and we can run that /backup.sh. Perfect. And now if we go into the /backups, list that out, we've got this 2024. So if we change directory into there, list it out, and we can cat, and we've got that hello.txt. So this is working. However, we do have this one issue where if the person runs it again on the same day, then it's going to fail. So maybe we want to put a check in for this and give a warning or something. So let's hop back over to the script and we'll add our last change here. So what I'm going to do is I'm actually going to delete all of this out, and we're going to add in a conditional statement that checks to see if that directory exists. And then based on whether it does, we'll perform one of two actions. If it does not exist, then we'll create it just as we did before. And if it does already exist, we'll print a warning to the user, because what's going to happen is that we'll just copy directly into the directory that already exists. And that's going to actually overwrite the contents of what's in that folder already. So the conditional statement we're going to use is called an if statement. And essentially the way that it works is we call if, and then we give some sort of statement that we want. And if that statement is true, then we execute the code in that. So the syntax, or the way to write this in Bash, is we will write if, and then we put an open and close square bracket. And what we put in that square bracket is the statement that we're checking to see if it's true. And I'm just going to write out the statement that we're going to use, and then I'll go over what it is. So we're going to go !d. We're going to go /backups $date. Okay, so what this is doing is this essentially saying if not directory backups /date. So essentially saying if the directory backups and then using that variable of date does not exist, then this will be true. And so we're going to execute this if statement. So on the next line in Bash, after an if statement, we then put then, and the then indicates what we do or what commands we execute. So we'll go to the next line, and then we use tab to indicate that we are inside of this if statement. So the first thing we're going to do is we'll just do an echo here actually. So I'm going to echo and we'll say something along the line of maybe backups date doesn't exist, creating directory. So that just lets us know that we hit that if statement, we're inside of it and it doesn't exist. So we're going to go and create that directory. Next thing we'll do is we'll just make that directory. So this is the exact same as we were doing before. So we'll go mkdir and it is that /backups date. Perfect. And that's all we need there. So if we just wanted to end this if statement here, then what we would do is we would come here and we would go fi, so if backwards, and in bash that ends this if statement. However, we wanted to execute a command or a line only if this if statement is not true. So the way currently this is going to work is the if statement will essentially check if that directory does not exist. And if it doesn't, then this is going to be true here. So that means we're going to execute the code in here. And we'll only execute the code between the then and the fi if in fact that directory doesn't exist. So what we want to do though is we want to have some code that executes only in the opposite of that. So only if that directory does exist. So what we'll do is in front of the fi, we're actually going to add in an else statement. And what the else does is essentially then it says, well, if this doesn't happen, instead do this, but only do this if the first condition is not met. So we need to add a tab here and we'll use echo. So we'll say something along the lines of like echo. We'll just do warning here and we'll say something like backups date already exists. Backup will overwrite. Perfect. So we can save this now and then let's hop back over and we'll rerun this and see if it works for us. So I'm already in that backups folder actually. And if we just do a quick reminder, let's cat out this hello.txt. It says hello backup. So I'm going to go back actually up to the root folder and we'll go into confidential. And I'm actually going to remove this hello.txt. And let's create a new hello.txt. So we'll do that with echo. And we're going to go hi overwrite into it. And we'll send that into hello.txt. Let's just cat that out, make sure it's all good. Perfect. So let's go back into the opt folder where we stored this script. And we'll run this backup.sh. Perfect. So that folder already existed, or that directory already existed. So we do get this warning now that backups already exist, backup will overwrite. So let's just double check and make sure that worked. So we're going to go into our backups folder. We've got that folder as we expected with the date. All right, and if we just list this out, we've got this hello. So let's cat out this hello.txt here. And we see that it overwrote it. So that worked as expected. Let's just double check now and make sure that it works when the folder doesn't exist. So let's go up one directory here and I'm going to delete the folder for today. So that's with this rm-r. I'll use tab autocomplete. We'll delete that. And now let's go over to our opt folder and we'll run this script again. Perfect. And we get the message that the directory doesn't exist and we're creating that directory. And just for a quick sanity check, we can go into backups, list it out, the directory is there. And if we go into that directory and we created that backup. Perfect. So using logical statements, especially the if and the else statement, can be very powerful in bash scripting. Again, this really just scratches the surface of what's possible with bash scripting. And if you are interested in this, then I would really encourage you to check out the additional resources and try and do some further learning on it. That wraps up this lesson. I'll see you over in the next one where we take a look at how we can actually schedule this script to run automatically. Welcome everyone. In the last couple of videos, we were taking a look at how we could automate performing the backup process of a folder by writing a bash script. And our intention for that bash script was that it was going to run daily. However, the only way that we had to trigger it was to actually run it manually from the terminal. Of course, this isn't going to make for a very good backup process if we have to remember to manually run it every day. And in this video, we're going to take a look at the Linux functionality for scheduling tasks to be run on a set schedule. And those are called cron jobs. So let's hop over to the terminal now and take a look at how we can actually configure those. Each user actually has their own set of cron jobs. And when a cron job triggers, it's going to run a command, the command that's specified in the configuration. And it's going to run that command as the user whose cron job it's for. So in my example here, I'm logged in as the Bertram user. And if we edit or add cron jobs for that user, then of course, when they trigger, they'll run as that user. So one thing to keep in mind, of course, is that the commands that we're running and any files or folders or things like that they're accessing, those will need to have the correct permissions set up for that user, because it's essentially the same as if I was at the terminal and running the command as that user. So each user then has their own configuration file that lays out the commands that are going to be run by the cron job and also schedules when it's going to be run. And we can interact with, view, and edit that configuration file with the cron tab command. To view a user's cron tab, we can go cron tab and then pass in the -L option. And that will list out the cron tab, but you can see I actually have not set up any cron jobs for this Bertram user, so it's saying there is no cron tab. We can edit the cron tab with the cron tab -E command, and then this is going to edit the configuration file, which is sometimes referred to as the cron tab file for that user. Now you could actually go out and find the location of this file and more manually edit it by opening it up with a text editor. But the best practice is actually to edit it using the cron tab command. So we'll do that right now. I'm going to hit cron tab -E, and then it's going to actually ask what editor we'd like to use, because we need to use an in-terminal editor. I'm going to use Nano because it says here it's the easiest, and it also probably is the easiest one to use. So I'm going to hit 1. If you prefer Vim, you're more than welcome to use that as well. So we'll hit 1. And then it's actually going to create a temp file for us to edit the cron tab. And then when we save it, it's going to run some checks to make sure that we did it properly before it actually writes it to the actual cron tab for this user. So you actually get a lot of good details in this file. If you ever forget about how to set these up, you can read through this. However, I'll just go through it so you don't have to read it, and I'll show you how to set up cron jobs. So we scroll down to the very bottom here. You can see that actually the last line tells us the format of how we need to set cron jobs. So the first 5 columns are for scheduling, and then the last one is just the command that's going to be run when that schedule is triggered. So I think the easiest way to actually show how this works and the scheduling works is just to put in one that will run every minute and then talk about how we could reschedule that. So to make one that runs every minute, we're actually going to go star. So that means any minute. Star for hour, that means any hour. Star for day of the month, that means any day of the month. Star for any month, and then star for any day of the week. And then we'll just do a very basic command of echo hello world. So in all of the time scheduling columns, we can put a star, and that basically means that it's true for all of them. So minutes, of course, can be any minute of the hour, 0 all the way up to 59. Hours, of course, can be all the way from 0 to 23. And then days of the month, of course, is all the way from 1 up to 31. Months is 1 to 12. And then day of the week is actually 1 to 7, where 1 is Monday and 7 is Sunday. So this one, of course, will run on every minute of every hour of every day of the month of every day of the week. So essentially this will run once every minute. If, for example, we wanted it to run once an hour, well, we could set this minute then to be a specific value in the hour. So for example, maybe we wanted it to run at the 45th minute of the hour. And what this is now going to do is that at the 45th minute of every hour, of every day of the month, of every month of the year, of every day of the week, it's going to run. So we've essentially now set it up to run once an hour at the 45th minute. Of course, we could change this, for example, then it would run at the 30th minute. Let's say, for example, instead of running on the 30th minute, we actually want this to trigger in the morning at 7:30. So what we can do here is make this a 7. And then what that's going to do is then it's going to run on the 7th hour and the 30th minute of every day of the month, every month of the year, every day of the week. So essentially now we have scheduled this to run at 7:30 in the morning. If, for example, we only wanted this maybe just to run on the first day of the month, we can do that as well. So we could change the day of the month to be 1. And now we're going to run on the first day of the month at 7:30. We can even go further. For example, maybe we only wanted this to run on Mondays. So we'll put this back to a star, and then we could go to day of the week and put this as a 1. And now it's going to run every Monday at 7:30. So let's put it back here actually to just run once a minute and see what that's going to look like when we save it. So we'll go here, we'll put this to stars here. And to save this, I'm going to hit Control X to exit, and it's going to ask me if I want to save the modified buffer. So I'm going to hit yes to save that, and it's going to ask me where to write, and we can just write it to the one that it defaults to. So we'll hit enter. Perfect. And if we run date here actually now quickly, so we're going to see that it's going to trigger. If I just run it again here, that's 5 seconds. So what I'll do is I'm going to give it another 10 seconds, and then we'll run this and we'll see how it triggers. Okay, so we just crossed over that threshold. So what we're going to do is we're going to clear this out, and you'll notice it didn't actually display to hello world, and that's because it's not actually going to print out to the terminal. So you'll notice that it actually did not print out to the terminal, and that's because those cron jobs are not actually going to print out to a terminal. They're not attached to a terminal. We can actually take a look though at the logs that are output when that cron job actually runs and make sure that they are in fact running. And the location to view that actually, if you want to cat it out, is going to be cat/var/log/syslog. And I can actually see right here we have this log where as Bertram, it runs the command echo hello world. And so we see that that actually triggered. It's not always best practice to actually run a cron job as a regular user. Generally, it will be better practice to create one of those system or service accounts and have those users actually run the cron jobs. So what we'll do now is we'll take a look at how we can create or edit a cron job for another user. And what we'll do is we will add a cron job for root that's going to go and run that backup script once a day for us. Before we do that, what I want to do though is quickly just go into that backups folder. And if I list it out here, you see we've got the folder from yesterday and one for today for me. So 28th is today. And what I'm going to do is I'm actually going to go ahead and remove the one for today. So we'll go sudo rm-r and I'll go 24 and then 28th day. Now if we list this out, the one for today is gone. So now when that cron job actually triggers, we can see that it actually ran properly. So I'll clear this out. So we can use the cron tab command actually to edit it for a user. But to do that, we're going to need to either be root or run it with sudo. So I'll go sudo and then it's cron tab -u to specify a different user. Will be root, and then we'll do the -e again. Perfect. So if I scroll down all the way here to where we were, let's take a look at how we can actually run one once a day to write this backup. So for me right now, it is 13:59. So what I'll do is maybe I'll run one to run at 2:02. So that's 3 minutes from now. So to do that, what I'm going to do is I want that to then run at the second minute. And it's going to be on the 14th hour. Remember, it's the 24-hour clock. And then I'll do star for day of the month, star for month, and star for day of the week. And this is telling the cron job then to run once a day at 14:02. And the command that we want to run is /opt /backup.sh. Remember, we need the full path here since we did not add the opt folder to our path. So what I'll do is I'll hit Control X here. And I'm going to hit Y to yes, save this to the buffer and enter. Perfect. And now if we actually go and rerun that again, but we go -L, can see that we have it set there. So for me right now, if I run date, it looks like we've got about 1 minute and 20 seconds until it's going to hit that time. So I'll wait until it rolls over to that time, and then we'll see if that folder got created. Just really quickly, again, we can go ls and confirm it's not here right now. Okay, so we just rolled over to 2:02, so let's run a quick ls here, and we see we have that one created for the 28th to today. So if we just quickly go in there And it looks like it was able to copy over all of the files. And of course, if we go and take a look at the logs where the cron jobs log to, that's again, if we use sudo and then cat, and it's in that /var/log/syslog. And if we take a look here, we can see there was the run that ran still for the Bertram user hello world, but also at the very top of the hour, the one ran with the .backup.sh and it ran successfully. So cron jobs are a very powerful tool for us to schedule and automate tasks in Linux. That wraps up this video. I'll see you over in the next one where we take a look at how we can update and install software on Linux. Welcome everyone. In this lesson, we're going to be learning about how we can use a package manager in Linux to both keep our packages up to date and also to install new packages. And when you hear packages, what we're generally referring to as software. So for example, throughout this section of the course, we've been using the GNOME text editor. This would be an example of a package. Now it came pre-installed on our operating system, but if it didn't, we could use our package manager to install it, and we can also use it to keep it up to date. You may recall from one of the very first lessons in this section of the course when we were learning about Linux distributions, frequently called distros, that one of the main components of a distro is its package manager. One of the most popular distributions or distros of Linux is Debian, and it has spawned many offshoots of distros that are based on Debian. You may hear them referred to actually as Debian based, and Ubuntu is an example of that. Debian makes use of the apt package manager. That's APT. It's an acronym and it stands for Advanced Package Tool. And that's the one that's used in Ubuntu and we'll be taking a look at today. Just keep in mind, if you are using other distros of Linux, then they may not actually be making use of the APT package manager or apt package manager. They may have their own different one. With that being said, let's hop over to the terminal now. So one of the really great things about the apt package manager is that it actually keeps track of all of the packages that are available, what version they are, what dependencies all those packages need, and where we can actually go out and install those. So where we can pull down those packages from the internet. In order for our local app tool to stay up to date, we actually need to make sure we sync it with those external repositories that are out in the internet. So that's the very first thing you should actually do generally before you're going to make any upgrades or install any new software. So I'm going to go ahead and show you how to do that right now. Anytime you're going to use the apt command, you're going to need to do that with sudo or broot. It requires those root privileges to be able to make changes with apt. So I'll run our first command here to actually update our apt repository. So we're going to sudo apt update. And it's of course going to ask me for the password. And I'll just let this run through. You can see here, it's actually was able to pull down those updates, and then it also gives us this information here. There's 12 packages that can be upgraded, and you can run apt list upgradable to see them. So let's do that right now. I'm going to go sudo apt list, and we'll go --upgradable. Perfect, and this gives us a list of packages that can be upgraded. So I'm just going to pause here and we'll just do a really quick recap here because this is something that I actually sometimes got confused with, and that's the difference between update and upgrade. So update is just telling the apt tool that we have locally on our computer what are the most recent versions of all of the software, what dependencies do they have, and also where can you go out and get this software. So after we ran update, you'll notice that it was able to go and pick up and see that there are some outdated versions of the software that we can upgrade. So when we use upgrade command, that's actually then going to go and upgrade our software, which means install the newest versions and any dependencies that they require. So let's take a look at how we can do that. So we can go and update all of those packages that need to be updated by running the sudo apt upgrade command. So we'll just do that right now. And it gives us a heads up actually that there's going to be 12 packages that are going to be updated, and that's those 12 that we saw. So What we can do now is we could hit yes and it will go through that, but I just want to show a shortcut here in case you don't want to wait for it to app prompt you. So I'll hit no, and I'm just going to clear this away. And what I'm going to do is I'm going to run that command again, but say for example, we would like to not actually have to sit here and wait until it pops that up and we just want it to run through that for us. We can use the -y option, and that's going to then not prompt us to hit yes for any of these yes or no questions. And this can be great also if you're running this as part of a script or something. So let's run this now. And you can see it automatically just goes out and it installs all of the packages that we need. Perfect, and that ran successfully. So that's how we can update and upgrade. I just want to show one other thing here quickly. So something you'll commonly see is that if you're going to run an upgrade, of course you want your repository to be updated because you want to know if there's any new updates. So frequently you'll see this done in one line. So what you'll see is it'll be sudo apt update, and then you'll see this and, which essentially means in bash, so run the very first command, and then after that's done, just go ahead and run the second command. So then you would run sudo apt upgrade. And if we run that, then that would allow us to both first update and then upgrade. So I'll hit run. You can see here, it actually doesn't find anything because we just ran them all, but that's how we could do it in one line. So that's how we keep our repository up to date and also how we upgrade packages. And it's really good to get in the habit of doing that pretty frequently, because this is what installs updates that both allow us to have new features and bug fixes, but it also keeps our system secure by getting any security patches or things like that for our packages. The next function we'll take a look at of the apt package manager is how we can actually install packages as well. So we do that with the sudo apt install command, and then we need to know the name of the package. So one package that I like to use instead of the GNOME text editor is a text editor called gedit. So I'm just going to show how we can install that right now. It's with gedit here. Perfect. So I was able to find that package and we can install it. Before we do, I just want to discuss what's being shown on the screen here and how this is a really nice feature of the apt package manager. So it actually knows the dependencies that we're going to need for this package itself. So gedit is relying on some underlying libraries or dependencies. That's that external code for it to be able to run. And the package manager knows that these dependencies are required for that package and also that we don't have them installed on our system. So it's suggesting that we should go and install those additional dependencies. And it even has some suggested packages, which are additional plugins. And it's just giving us a warning here that it's going to install these additional packages and how much space that's going to take. So I'm going to hit yes, actually, and we'll just let that run through. Perfect. And we were able to install gedit. So now we could launch it and use it. So let's just launch gedit here to make sure it's working. You can see we get this text editor that's not all too different from the GNOME text editor. Perfect. So we can actually also use the apt package manager to uninstall packages if we no longer need them. So let's take a look at how to do that. It would be sudo apt, and then the command is remove, and then the package name. So let's just go ahead and remove gedit actually. And it's going to tell us how much disk space will be freed. So let's hit yes. Perfect. And if I just clear this away now and we run gedit, actually see that it's not there. So we are not able to actually run this command because it has been removed. That wraps up this video on how we can use the apt package manager to update, install, or remove packages from our system. I'll see you over in the next video. Welcome everyone. In the last video, we took a look at how we can use the package manager to keep our packages up to date, and that's by using it to upgrade them to the latest versions. That is just for the packages though, and not the operating system. So what we're going to look at quickly in this video is one of the methods in Ubuntu to actually update the operating system if there are any updates or upgrades available. So I'm going to hop over to my VM now and let's take a look. I'll link the official steps from the Ubuntu website below, but the first thing they actually recommend is that we should both run an apt update and an apt upgrade before performing the update to the operating system. So I just did those in the last video and I was recording, so I will skip that step, but I wanted to mention that that is the actual first step we should run. So after that, we can use the graphical user interface that Ubuntu has for updating itself. And if you go into apps and then we go to the software updater, we can actually launch that. And the first thing it's going to do is actually check for updates. Perfect. And if we take a look here, we can take a look at the details of the updates, and it looks like there are some security updates. So what I'll do is I'm actually just going to make this a little bit bigger here. And I'm going to hit install now to actually install these important security updates. Just going to run through here. And now it just gives us the heads up that the software on this computer is up to date. So it's always good to check for those updates and make sure we're running any important security ones for sure. Just a really quick video here on how we can do this on Ubuntu. Remember, it's going to be different for different distributions, so you may need to go out and search for the proper way to do it. I'll link the full steps from Ubuntu as well in the description. That wraps up this video. I'll see you over in the next one. Welcome everyone. So this is going to just be a really quick outro for this section of the course, as it is the last video on the Linux section of the course. Just going to quickly talk about some of the important or core things that we learned in this section of the course, and also provide some additional resources should you want to do more learning about Linux itself. Before we dig into it though, I do just want to give a really big congratulations on making it through this section of the course. We learned about some really core and integral topics, like what the Linux operating system is, what it's used for, and why it's so important to know about. We went ahead and installed Ubuntu on a virtual machine, and then we used that to learn about the Linux terminal. We then used the terminal to actually write some scripts, update our software, and even schedule some tasks. If you're not familiar with using the Linux terminal, then this may have been a big step for you, and it will take a little while to get comfortable. If you're still not feeling fully comfortable with it by the end of this section of the course, that's okay. I would say stick with it, and whenever you get the chance to try and use it, if you can, try to use that over the UI methods and just stick with using the terminal, and it will start to become more second nature. I'm just going to hop over to my browser now and show you two great additional resources in case you want to learn more about Linux. The very first resource that I want to show is actually another course on the TCM Academy. It's our Linux 101 course. It's an excellent course. I've taken it myself. It covers some of the same fundamental core topics that we go over in this lesson, but it goes a lot more in depth. It's about 4 hours long and is an excellent course. The instructor, Brent, is an excellent instructor, and he actually taught this as a university professor, so he really knows his stuff. I'd suggest taking this course if you want to learn more about Linux. The second one, if you're looking for a free option, is on our YouTube. We have a 2-hour video. It's called Linux for Ethical Hackers, and it's free out on our YouTube, which is the Cyber Mentor. I'll link it down below. And this is another great resource if you're looking for a free option. That wraps up this section of the course. I'll see you over in the next one. If you've made it this far in the course, then great job. Unfortunately, this is where I have to end the YouTube version of this course, because if I add the next section on networking, then it will actually go over the 12-hour limit that YouTube has for uploading videos. Again, if you are interested in taking the full version of this course in a more structured format that will also give you a certificate of completion at the end, then make sure to sign up for the free tier of the TCM Security Academy. You can get access to this course and 3 other courses entirely free with no credit card required. In addition to that, if you are interested in pursuing a help desk or entry-level IT role, we also offer the Practical Help Desk Associate Certification. This is a real-world, practical-focused certification where you will be challenged in a simulated business environment to close tickets that an actual help desk technician would in a real-life job. That wraps up this video. I hope to see you over in the Academy to finish up the last 6.5 hours of this course.